Hey guys, so you should already have your calculator and pouch out on your desk, as well as your journal headed with the first page being 1-4, Solving Proportions. Today is September 8th, 2016. Don't forget to label the right hand of the page in the top corner, the page number you're on, and fill out the table of contents. As you're doing that, or maybe you're already finished, what you're going to be given is either the whole sheet or a half sheet that you will cut. And what I want you to do is at the top it says 1-4 notes. I want you to take that half sheet and go ahead and glue that in. There's some examples that we're going to be discussing, as well as some definitions and so forth. So take a second to go ahead and glue that in, and then we'll begin. So the first thing I want to talk about is proportions. You guys spent a lot of time in 7th grade pre-AP doing proportions and solving proportions. So let's define what a proportion is before we even begin. What is a proportion? Okay, I'm going to write the definition and then it probably will come back to you. But a proportion is an equation that states when two ratios, in that case could look like two fractions, are equal. And if I draw a picture using algebraic terms, I could have A over B, remember these variables could be any number, is equal to C over D. This ratio on the left side, A over B, is equal to C over D. So this fraction is equal to this fraction. Okay, that's what a proportion is. So go ahead and take your highlighter and highlight that, and I'm going to put a box around our example. So what we want to do is sometimes one of these letters will be missing, and we have to figure out what that number represents, or what that letter is, what number that letter is, to make it equal to the other fraction. So there's really two ways of solving this. And we're going to do both ways. Two ways to solve. Okay, the first way is what we're going to do number 1 with, or solve number 1 with. And that way is by using the scale factor. Or I'm going to say multiplier. And now we can't use this every single time. In 7th grade you probably were able to use it a lot more, but when in algebra it's going to be a little bit more challenging. So the first way of solving this first proportion is by using the scale factor. So I'm looking to see, okay, if I will know 3/4 is equal to A over 12. I'm looking to see, okay, well, how did I get from 4 to 12? What would I have to do? And again, this is a multiplier. So what do I have to multiply 4 by to get 12? I'd have to multiply that by 3. Now, whatever I multiply the bottom or the denominators by, I'm going to have to do to the top the same direction. So since I did 4 times 3 equals 12, I have to do 3 times 3, which means my A is equal to what number? You should have gotten 9. Now when I type this into my calculator, remember scale factor or proportion means they're equal on both sides. So if I have 3/4, so I'm going to put 3 divided by 4 is 0.75. We found A to be 9. So if I do 9 over 12, it should be 0.75. Okay, because they're equal, they should be equal on my calculator. Okay, that states that these two ratios are equal. That's a proportion. So the first way is by a scale factor. It won't always be that easy, so that's why we have another way of solving proportions, and that's what we're going to do example 2 with. But let's write down the definition first. So the second way of solving a proportion is by cross multiplying. Okay, and how we cross multiply is that we multiply the denominator of one ratio to the numerator of the other ratio. Okay, so again, cross multiplying, or sometimes you might have heard it as butterfly. We multiply the denominator of one ratio to the numerator of the other ratio. So when I say butterfly, that might make more sense to you depending on how you learned it. But if I look at this proportion, I have 2/5 is equal to k over 12. So we want to figure out what number could k be to make both these ratios equal. So cross multiplying means you are going to circle what is across from each other. So 2 and 18 and k and 5. Okay, that's why it makes a butterfly, because I have my line down the middle. So when I rewrite this, now since I cross multiply, I multiply what's being circled. So I have 2 times 18 on one side and 5 times k on the other. Now it doesn't matter what side is which, okay? And it doesn't matter what order. I could do 18 times 2 or k times 5. When I multiply these two together, 2 times 18 is 36. 5 times k is 5k. From here, I have a one-step equation. How do I isolate k or get k by itself? Right now it's 5 times k, so the opposite of multiplication or inverse operation would be to divide by 5. Cancels out, and I would divide by 5 on the 36. And I end up getting 36 divided by 5, which is 7.2. So k has to be 7.2 to make both ratios equal. Now if I check that, 2/5 is equal to, we found k to be 7.2 over 18. Okay, let's check our calculator. So if I have 2/5, 2/5 is 0.40. We want to make sure 7.2 over 18 is the same, which is 0.40. So I know I did that correct if both my ratios are equal. Okay? So there's two ways of solving this. Again, there's no way I could have figured out scale factor, because again, I'd have to multiply by a decimal. So that's why cross multiplying works every single time. Scale factor doesn't. So go ahead and try this next one by yourself. I want you to really focus on the cross multiplying, so go ahead and do that. Give you a couple minutes to work on that, and then when everyone's ready, we'll push play so you can go over the... Okay, so if I cross multiply, I end up getting 3 times q on one side times negative 15 times 1 on the other. I'm left over with 3q is equal to negative 15, so I have to divide by the coefficient of 3, which leaves me with q is equal to negative 5. Now I can double check that with using my scale factor. If I look at the two denominators, since there's both numbers there, I go from 3 times what gives me negative 15. It'd have to be times negative 5. So I'd have to go 1 times negative 5 would have to be negative 5, which means I did that correctly because I checked it both ways. Okay, so that's basic computation of our two ways. You also have focused a lot on word problems when it comes to proportions. So for this one, it says Jennifer is ordering cake for her wedding reception. If one cake will feed 18 people, how many cakes does she need in order to feed 150 people? So you probably learned from these word problems to set up a WGU. Okay, so we're talking about ordering cake for a wedding reception. So we're looking for words that are familiar. Okay, and we're looking for numbers. There should always be 3 numbers when we're setting up a proportion, because we usually have to find the 4th. So it says if one cake, so there's my first word, will feed 18 people. Okay, so far, if I set up my WGU, okay, the two words that I have are cakes and people. So it doesn't matter which one you put first. I'm going to put cake on top, people on the bottom. And it says one cake will feed 18 people. That's given to us. That information is given. So I'm going to fill it in. One cake feeds 18 people. Okay, the next sentence, it wants us to find how many cakes does she need in order to feed 150 people. So they give us information of 150 people. we want to know how many cakes does that feed. So I'm going to put a variable x there to represent how many cakes she's going to need. So here's my WGU. Now just to refresh our memories of WGU, I want you to write this information at the top or somewhere on the open area. Okay, what WGU actually stands for? The W stands for the words. Okay, usually it's 2 units that are given to us. So in this case, it would be people and cake. You're going to be able to pick out the words pretty easily. Okay, G represents the numbers given. So usually it's in one sentence, but you just have to look for them. Usually there's 3 given, okay, but these 2 given are usually in one sentence. And then this one is the unknown number. That's what we're solving for. Okay, so that's what our WGU stands for. Now, since our WGU is set up as 2 ratios, 1 over 18 and x over 150, I'm going to rewrite it. The WGU just helps you set up the proportion. So now I'm actually going to write the proportion. So I have 1 over 18 is equal to x over 150. From here, I'm going to go ahead and cross multiply. So again, I want to solve for x. So I'm going to cross multiply, draw my butterfly. So I have 1 times 150 on the left and 18 times x on the right, which leaves me with 150 is equal to 18x. Now the last step here is to divide by the coefficient of 18 on both sides. So when I plug that in my calculator, I have 150 divided by 18, which is 8.33333. So my variable here is equal to 8.3 repeating. Now let's go back and check to make sure that answers our question. It says, how many cakes does she need in order to feed 150 people? Does that make sense? 8.33 cakes. No, okay, I can't have a third of a cake, or I'm not going to make or order a third of a cake. So the answer here is I need to order 9 cakes. That would be my answer. Okay, so always make sure you go back and answer the question, because that would not be the correct answer here. I would have to order 9. Now, that's all review from 7th grade, so why are we doing that now in algebra? Now let's take a look at the next couple proportions. We'll take a look at the first one on the left. It says negative 4 over 5 is equal to 3 over z minus 5. So instead of having 2 ratios with numbers just on the top and the bottom, we now have a variable here. I'm going to go ahead and draw a line down the z so it helps me figure that out. Now, whenever you have more than one number, or a variable and a number, I'm going to put that in parentheses. So put that denominator of the second ratio in parentheses. And just like any proportion, I'm going to go ahead and cross multiply to solve. So when I cross multiply, I'm going to rewrite what I have. Exactly what I have. I have negative 4 times z minus 5 is equal to 3 times 5. Okay, so see how I did that? I just rewrote what I had. Negative 4 times z minus 5, and then 3 times 5. Now, how do I get rid of these parentheses if I have a variable and a number inside? What do I have to do? I'm going to have to distribute that negative 4 times everything in the parentheses, which leaves me with negative 4z times, or we'll decide that it is, negative 4 times negative 5 is a positive 20, so that's on the left side, equals 3 times 5, which is 15. So now I have a two-step equation here. I want to get z by itself. So I'm going to go ahead and get rid of the number not attached to the variable. So I'm going to take away 20 on both sides. And that leaves me with negative 4z is equal to 15 minus 20 is negative 5. I'm going to divide by the coefficient of negative 4 on both sides. And my answer here, negative 5 over negative 4, is a positive number, and it leaves me with 1.25, or 1 1/4. So the answer for Z here would be 1.25, to give me a proportion with two ratios that are equal to each other. Okay, now I want you to go ahead and try solving this next one by yourself after just one example that we did together. Okay, again I have 4v minus 2 over 8v is equal to 2/3. Go ahead and work with your neighbor if you need to. Give you a couple minutes, and when everyone's close to being finished, we'll go over it and discuss. Okay, so again, to solve this proportion, I'm going to cross multiply. Whenever you see an equal to with two ratios, we're going to do a proportion. So, first thing I actually should have done is put this in parentheses. Anything that's not just the number. So now I should have on one side 3 times 4v minus 2 in parentheses is equal to 2 times 8v. So make sure you have that written down. Now, I'm going to have to distribute that 3 to all the numbers on the inside of the parentheses on the left side. So 3 times 4v is 12v, and 3 times negative 2 is negative 6. Over on the right side, 2 times 8v is just 16v. So I want to get v by itself. I have v on both sides, so let's get the v's together. So it doesn't matter which one you move. I'm going to go ahead and move this 12v over. So I'm going to subtract 12v on the left and subtract 12v on the right, which leaves me with negative 6 is equal to 16v minus 12v is 4v. And the last step here is to get v by itself, 1v. I'm going to divide by the coefficient of 4. And my answer ends up being v is equal to negative 1.5. Remember, whenever I divide a positive and a negative, my answer ends up being negative. So your answer should have been v is equal to negative 1.5. And if I plug that in for both the v's, it should be equal on both sides of that equal to sign. Okay, so that's solving proportions. Along with solving proportions is proportions, and then we are sometimes given similar figures. So on the next page of your journal, let's go ahead and head it first, and then we're going to glue in the other part of notes. So go ahead and label it 1-5, proportions, and similar figures. Again, today is the 8th of September, and this is my page 21. And once you have that labeled, you're going to glue in this other half sheet that has 1-5 notes at the top. And it says proportions and similar figures. So go ahead and take a second to head your journal and glue that in. Alright, once you have that glued in, now we're looking at similar figures. So let's look at this first example a little closer. It says the figure in each pair is similar. Identify the corresponding sides and angles. So if you notice this little sign right here, it looks like a squiggly. Okay, sometimes you'll actually see an equal to underneath that, and that just means congruent to. Okay, so we're trying to figure out what sides are congruent to the other side lengths. So what I like to do first is to pick the angles. Okay, so if I say angle M, and you write that as angle M is congruent to what angle on this triangle? Okay, since it's the bottom left corner here and they look very similar in their shape, I'm going to say angle M is congruent to angle P. And you can use different colors if you want. Again, these are your notes, so you can use whatever you want on them to make sure that you understand the concept. Okay, if I choose another angle, let's say angle N. What angle is angle N congruent to on the smaller triangle? Okay, you should have said angle Q. Which leaves the last two angles, angle O and angle R, are congruent to each other. Okay, so once we're able to identify that, then we're able to figure out what side lengths are actually congruent to each other as well. Okay, or similar, the side lengths. So if I write those off to this side, let's say side lengths. Okay, if I choose side length M to N, so I went from my green angle to my orange angle. So line segment M to N looks like that. What is that similar to? What side length on the small one? M to N, green to orange, is similar to P to Q, green to orange. So I'm going to highlight that to show that those are similar side lengths. So I'm going to put M to N over P to Q. Okay, if I do another one, let's do N to O. So I'm going to use my pink highlighter. Line segment N to O, or again, if I look at my angles go from orange to pink, so orange to pink over here would be Q to R. And then the last one, if I say O to M, okay, I went from my pink angle to my green angle, so I'd have to go pink to green here. It's similar to line segment RP. Okay, so that's just identifying similar side lengths and angles that are congruent to each other. So let's go ahead and solve for a missing side length of similar figures. So this next figure says the figures in each pair are similar. Okay, find the missing side length. So they give us this small right triangle. Looks like a right triangle. It's not identified, so I'm not going to identify it. But I have two side lengths. I have 5.2 and 4.8 and 19.2 and X. They want me to find the missing side length that is labeled X. So you can do this a couple different ways. Okay, I'm going to pick, let's say, 4.8. We'll start off with that. So I'm going to put 4.8 over, what side is 4.8 similar to on the bigger triangle? Okay, it's similar to the 19.2. So I'm going to go ahead and put that underneath it. 4.8 over 19.2. That's one ratio because those are similar side lengths. Okay, if I do the next one, 5.2. Now notice both the small sides of the triangle are my numerators, is similar to the X. Now you could have set this up many, many, many different ways. Okay, but the one thing that's important here is no matter how you set that up, you need to make sure when I'm solving this proportion that you are multiplying 4.8 times X. So however you set that up, if you're multiplying 4.8 times X, great, then you did it correctly. Okay, because no matter what, you're going to be multiplying 19.2 times 5.2. So if I go ahead and solve this, okay, one side I have 4.8 times X, which is 4.8X. And then if I use my calculator, I'm going to multiply 19.2 times 5.2, which gives me 99.84. Okay, I want to find the missing side length, which is the X, so I have to divide by the coefficient of 4.8 on both sides. Again, I'm going to use my calculator. And I end up getting X is equal to 20.8. Now, let's double check. Okay, so if I found that X is 20.8, I'm going to go ahead and label that back on my picture. I'm going to put that also right here. Because again, a proportion means they're equal on both sides. So if I take this first fraction, okay, so let's do 4.8 divided by 19.2. Okay, that ends up giving me 0.25. So this ratio is 0.25. Let's check what we found. So if I do 5.2 divided by what we found, 20.8, I end up getting 0.25, which means they're equal, so that makes it a proportion. So I know I did that correctly. Okay, so that's, again, solving for missing side lengths. Go ahead and do the second one by yourself, and then check with your neighbor, and then when you're done, we'll push play to go over it. Okay, so it gives me triangle A, B, and C is similar to D, E, and F. Okay, they want us to find line segment AC. So we need to figure out what this line segment right here is, and they don't label it for us, so I'm going to go ahead and label that. Now they give us a whole bunch of different numbers, but I'm not going to use all four of these because, again, I want to find two similar side lengths. So let's start off with the one that we need to solve for. If I have X as A to C, what side length is that congruent to or similar to on this side? Okay, it's similar to D to F, which is 18. So there's one ratio right there, X over 18. Now, I need to find another ratio with sides that are similar. So if I look at this 10, okay, this side length would be 10. What side length is that similar to? It's similar to D to E, but they don't give us that measurement. So they throw that in there to confuse us, but really 10 is not needed. We don't have to use 10 in this information because we don't have the rest of the information to set up the proportion. So I'm going to use the B to C. Okay, so B to C is 16 and E to F is 12. Now remember, if I chose this first one, A to C should be on the top and my B to C should be on the top. This is triangle, the big one, and this is the small one. So notice that's my ratios. And now I'm ready to solve. So I'm going to cross multiply on both sides. I get 12 times X on one side. 16 times 18 is 288. I'm going to divide by the coefficient of 12, which leaves me with my answer as X is equal to 24. Okay, so again, A to C would have to be 24. Okay, the last question is a word problem. So it says, a man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What is the height of the flagpole? So I'm going to draw a picture for this one. So we're going to draw a guy that's 6 feet tall. Okay, so here's his height. And he is standing next to a flagpole. So here's the flagpole. And it says the shadow of the man is 3.5 feet. So if this is my 6-foot guy, okay, his shadow here is 3.5 because the sun's shining and so forth. Okay, so I'm just going to go make a triangle because it looks like a triangle. My 6-foot man has a shadow that's 3.5 feet. It says the shadow of the flagpole is 17.5 feet. So here's my flagpole. The shadow is 17.5. It wants us to figure out what is the height of the flagpole. So my variable goes where the flagpole is. So let's go ahead and solve. And you could have done a WGE for this one as well. But we're going to draw a picture. Okay, so let's begin. Okay, we'll pick the man first. That matches up with the height of the flagpole. So the man is 6 feet tall. We want to know how tall is the flagpole. That's one proportion. And then I have 3.5 over 17.5. Okay, again, no matter how you set this up, you should have these two things being multiplied by each other. So if I do my cross multiplication, I have 6 times 17.5 is 105 is equal to 3.5 times x is 3.5x. I'm going to divide by the coefficient of 3.5 on both sides. And x gives me 30 here. And again, the question's asking me what is the height of the flagpole. So the height here of the flagpole would be 30 feet. Okay, so again, a lot of this is just review, but maybe something from the 1.4 notes of proportions with a couple terms as the numerator denominator is new to you, and we're going to practice that on our assignment. So go ahead and keep your notes off to the side. What you're going to need is a separate piece of paper, so go ahead and get that out and head it. We'll have someone come around and hand out the homework to you, and then we're going to go over one or two before we begin, and then you'll have the rest of the time in class to work on it. Whatever is not finished is your homework. Okay, so your homework is two-sided. The first side says 1-4, solving proportions. So if you look at numbers 1 through 4, okay, what you're going to be doing is solving for that missing variable. So if we do that first one together, go ahead and write 1 on that paper that you just headed, and put the problem down. So 3 over n is equal to 2/3. Now again, there's two ways of solving this, with scale factor as well as cross multiplication. I really want you to focus on cross multiplication, so let's work on that. So I want to see your work, so show me your cross multiplication, your butterfly. Write out what you know. Okay, so 3 times 3 is on one side, 2 times n is on the other. Again, you must show me all your work, so that's why we're doing this one together. I have 9 is equal to 2n. I'm going to divide each side by 2. And my answer here, 9 divided by 2 is 4.5. I'm going to circle my answer. And back on the paper, I'm going to write down n is equal to 4.5, and I'm going to circle that or highlight that, whatever you prefer. Okay? So show me your work for those. Okay? 5, 6, and 7 are all word problems. So you're going to have to set up a WGU to solve that. Again, just like our notes, look at the example in our notes and that will help you solve. Okay? 8 through 11. Okay, we have proportions. This is the algebraic way of solving proportions. So again, whenever we have more than a number as the numerator and denominator, we want to put parentheses around it. So go ahead and do that now. So number 8 should be n plus 4 in parentheses. Number 9, you should have z minus 8 in parentheses. 10, you actually have 2 sets of parentheses, and so does 11. So again, you're solving it the same way. Look at your example if you need it. 12 is again another word problem, a little bit more challenging, so take your time on that. Make sure you're answering the question. On the back, 1.5, again, this was our similar figures. So it says the figures in each pair are similar. Identify the corresponding sides and angles. Let's just do angles here. So what I'm looking for number 13 is angle S. If this is my angle S, what angle is that corresponding to on the smaller one? Okay, it corresponds with angle W. So you're going to fill those in, just the angles. You don't have to do side lengths, so you can cross that part out in directions. (14) and 15 are similar figures, so set up your proportion and solve. Again, show me all your work. And then 16, A and B is a word problem. Okay, with remodeling a room addition. Okay, so again, whenever you don't finish this homework, you have the rest of the time in class to work on this today. Use your notes, keep those open, use your calculator, and we will grade this first thing tomorrow. Have a great day.